Welcome fans to Mike Busters!
Hola fans, it's that beeper again, and you know what that means. It's mail time! Now today's mail is from Harry Ferguson. Harry writes, Dear Michael, I was watching Space Jam the other day, and I saw a scene where the aliens turned Michael Jordan into a little ball. And I was wondering, is it possible for him to be bouncing around like that? And is the projectile motions really physically possible? Well, Harry, we'll figure out that answer now with our special.
The Mike Buster 3000 show, and we are
Ready to bust some myths!
Now, before we talk about the actual physics behind it, I want our viewers to know what the actual movie is about. Space Jam is a movie where 5 alien dudes come to Looney Tunes World and play them in a basketball game. Now, the 5 alien dudes seemed tiny and puny at the time, but they took the basketball talents of 5 NBA greats, including Sixers' own Charles Barkley. Once the alien dudes took the powers, they became huge and muscular. So the Looney Tunes could not play basketball against them, but they needed help. They needed Michael Jordan's help, who was the NBA's best player at the time, maybe even NBA's best player ever, to help defeat the alien dude. Now we just saw the scene that Harry Ferguson was talking about. Let's go and replay and see if this scene is real or myth.
Hey, everybody.
We will replay the video again with special data analysis done by a very special producer, Mr. Lager Pro. This is a real life video of me throwing a soccer ball in me house. This is a position versus time graph in the Space Jam video. X represents horizontal motion and blue represents vertical motion. In the position versus time graph, you can see where the ball moved and how far it went. This is a velocity versus time graph in the Space Jam video. The same color codes apply. Blue represents vertical and red represents horizontal. Now, we will be doing some analysis. As you can see, the red line slope is negative 0.88 miles per second. Since its slope is really close to zero, its change in speed is really hard to see by the naked eye. But you can see now that the blue line slope is negative 10.95 meters per second. The number should be negative 9.8 meters per second in order to be realistic. Now the reason that is 9.8 meters per second is because gravity is having the initial effect on it. So think about this, guys. In a velocity versus time graph, the acceleration should be straight like a linear line. So whenever the ball is bounced, jumped, thrown, kicked, whatever, its acceleration should be decreasing by 9.8 meters per second until it reaches its highest point, which is 0. And that is as far as it can go, or the tippy top highest it can go. And then the acceleration should be increasing downwards 9.8 meters per second until gravity has hit it fully to the ground and the forces have been balanced. Finally, I got it. This is the position versus time graph from the video before. As you can see, it's almost identical to the video Space Jam video, just with less dots. Again, red represents horizontal and blue represents vertical. Here is the velocity versus time graph in the video before. As you can see, again, it's also almost identical to the Space Jam video, with the red horizontal slope being negative 0.32 and the blue horizontal slope being negative 9.30. Again, same rules apply from the last Space Jam video. See? It almost looks exactly similar, doesn't it? Maybe the Space Jam video is real. Now show the motion maps and the force diagrams to also prove how they are similar. Here is the horizontal motion map of the Space Jam video. As you can see, each dot is constant, which means that every dot on the horizontal line is constant. Now here's the vertical motion map for the Space Jam video. As you can see, each dot has two arrows except for the toppest one, which has one arrow pointing in the direction that it's going. Each of the two arrows represent either if it's going up and down or left to right. You can also tell that each point is mostly constant. Now here are the force diagrams in the projectile motion of the Space Jam video. Now when the projectile motion is going up, the force of the bounce and gravity is affecting Michael Jordan in the Space Jam. At the very top for like a millisecond, the force of bounce and the force of gravity are balancing Michael Jordan. And finally, at the end, the only force that has any effect on Michael Jordan in the video is gravity. Otherwise, it would not be a projectile motion. Now, I repeat, the only force that's affecting Michael Jordan in the last part of the video is the force of gravity. Otherwise, it would not be a projectile. Now, here's the motion map for the real-life video. As you can see, it's very similar to the Space Jam video, only going the other direction because it was thrown in the other direction. Now, here's the vertical motion of the real video. You can also see it is again very similar to the Space Jam video, only it was thrown in the other direction. Now here's the force diagram of the last video. I repeat, it is exactly the same as it is in the Space Jam video. Repeat, exactly the same. Especially the last part, which gravity is the only force affecting it, otherwise it would not be a projectile. Now, here are the equations to help prove how they are similar, or prove how they are a myth. This is the y displacement for the vertical graph. Displacement y equals 1/2 acceleration times time squared plus starting velocity times time. We use this equation to go and find the time because we found all the other variables. So then we plug in all the equations, and then we do order of operations first. We do all the order of operations first. Once we plug in all the variables and do PDOS, we have to now put everything in ax plus bx plus c form. We do that because we have to find t, and we can't find it by t squared and t because they're two different variables. Once we have ax plus bx plus c form, this is the quadratic formula that we will use. We use the quadratic formula because, well, it's easier for people. So here's us just plugging in the equation. Once we figure out the equation, we should have two answers. Pick the positive answer because time goes positive. And finally, we should get time equals 0.305 seconds. Here is the equation to find the x vertical axis. Starting velocity times time plus 1/2 acceleration times time squared. Since the starting velocity should be 0, the plus after the plus part should always be 0. We are now left with 10 equals time times time equals displacement x. And since we know what time is, we should get displacement x at 3.05. Here's the problems again with the real life video. Here's the quadratic formula again. Here's more of the plugging in of the variables. Finally, we should get time equals 0.3. Here's the x displacement, same thing again. And finally, we should get displacement of x equals 3.
Information and data that you and the producers have shown me, I've come to the conclusion that the Space Jam video is a fact!
Well, there you have it. This Space Jam video is physically possible, although highly unlikely though, because the odds of 5 alien dudes coming down and turning me into a basketball is, well, I hope some to none. But we'll save that for another myth story. Until then, I'm Mike Sanders, and that was your Mike Busters episode. Woohoo!
ではここで一句コロトックタエなる調べコロコロとみんなもポケモンゲットじゃぞ
「